Hi, welcome to Radiant Minds Academy. We are asked to resolve interpartial fraction x plus 1 divided by x minus 2, all enclosed in a bracket, multiply by x minus 1, all enclosed in a bracket. So the fraction is x plus 1, all divided by x minus 2, multiply by x minus 1. So at this point, since the denominator is a linear factor, the fraction is resolved into partial fraction of the form a divided by x minus 2 plus b divided by x minus 1. Let's go here equation 1. Now, if you don't know how I resolve this into partial fraction, watch my video on this playlist on the rules of resolving partial fraction. The video will guide you on how to resolve a compound fraction into a partial fraction. Now, the next step is to take LCM at the right hand side. So if we take LCM, we have that this is x minus 2 multiplied by x minus 1. So having taken LCM, the denominator now becomes a, open bracket, x minus 1 plus b, open bracket, x minus 2. Now at this point, since the denominators are equal, the equation can now be written as x plus 1 is equal to a multiplied by x minus 1 plus b multiplied by x minus 2. So at this point, we can open up the bracket at the right hand side. So we have that this is a multiplied by s is ax, a multiplied by negative 1 is negative a, plus b multiplied by s is bx, b multiplied by negative 2 is negative 2b. And if we collect like terms, this can be ax plus bx minus a minus 2b. So at this point, if we factorize the expression here, we have that this is a plus b all multiplied by x minus a minus 2b. And we have here to be x plus 1. Now at this point, we can obtain the values of a and b using the cover-up method or comparing coefficient method. But in this video, we'll be using the comparing coefficient method. Now look at the equation. At the left-hand side, we have a coefficient of x, which is 1. And also at the right-hand side, we have a coefficient of s, which is a plus b. So we have that this is a plus b equal to 1. And also this is minus a minus 2b equal to 1. Let's call here equation 1 and then call here equation 2. Now we have a linear equation of two unknown, which we can solve simultaneously. So from equation 1, we have that a plus b is equal to 1. Thus, a is equal to, so if b move over to the right hand side, we have that this is 1 minus b. Now, to obtain the value of b, we substitute this expression into equation 2. Thus, equation 2 becomes, we have minus 1 minus b minus 2b equal to 1. Now we can open up the bracket here. We have minus 1 plus b minus 2b is equal to 1. So at this point, b minus 2b is minus b. So we have minus 1 minus b equal to 1. So if we move our negative 1 to the right hand side, we have minus b equal to 1 plus 1, which is equal to 2. So therefore, minus b is equal to 2. Thus, b is equal to negative 2. So at this point, we have obtained the value of b. Now, let us obtain the value of a. We substitute b equal to negative 2 into equation 1 or equation 2. So our equation 1 is giving us a plus b equal to 1. Now the value of b is negative 2, so we have that this is a minus 2 equal to 1. So if we move negative 2 to the right hand side, we have that a is equal to 1 plus 2, which is equal to 3. Thus, a is equal to 3. So at this point, we have obtained a to be equal to 3 and obtained b to be equal to negative 2. So from our compound algebraic fraction, we have that x plus 1 all divided by x minus 2 enclosed in the bracket multiplied by x minus 1 is resolved to a divided by x minus 2 plus b divided by x minus 1. Recall that the value of b is negative 2 and the value of a is 3. So therefore, the expression at the right hand side becomes 3 divided by x minus 2 minus 2 divided by x minus 1. So at this point, we have been able to resolve the compound algebraic fraction into partial fraction. Thank you so much for watching. And if you know you found the video helpful, please encourage us by liking this video and subscribing to our channel. Thank you once again. Also, for more videos on the concept of partial fraction that have quadratic denominators or that have repeated factors, and also the ones that have improper fraction, do not forget to check out our playlist in this channel on partial fraction. Thank you so much, and I wish you a happy learning journey. Bye.